Right. Everything should be up and running now. Uh, Link posted in all the right places. So welcome back. I didn't have time for stream yesterday, unfortunately. Some friends asked me if I wanted to join their quiz team for the evening. I couldn't say no to that. Leave them hanging. So I spent my evening yesterday on a quiz, drinking beer instead. So today I was thinking that we do both 5 and 6. Hopefully I have time for that. I mean I haven't looked at these, which is part of the thing. So I haven't looked at these. I have no idea how hard they are. So I might stumble into the first one and just get horribly stuck on part 1 and not be able to do any of them. But hopefully we'll be able to do both day 5 and day 6 here today. If we have some time at the end of this, I also have someone else's solution that I want to go through. Or at least have a look at. I had a look at it already. It's from day 4. And they've been asking on the forums for some help, and I figured I'd take a look and see what was going on. As you can see on my GitHub, we have up to day 4, but not 5 or 6. And of course in here we only have day 4. So we're gonna jump into day 5 here. Oops. I see a lot of people have created like a collection of scripts for their solutions, or some like common libraries and stuff. I probably should do that to speed things up a bit. Ambitious. Oh, someone on YouTube saying that 5 is hard. They've heard that 5 is hard. Well, I guess we'll find out soon enough. Day 5. If you give a seed fertilizer, you take the boat and find the gardener right where you were told he would be, managing a giant garden that looks more like a farm. A water source? Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. And there's a Wikipedia link on sand filtering. Can't make snow with dirty water. Well, kinda can. Not sure where he got that idea from. Don't worry, I'm sure we'll get more sand soon. We only turned off the water a few days, weeks. Oh no. His face sinks into a look of horrified realization. I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island Almanac, and it's a Wikipedia article on just the word almanac, the concept of an almanac. Which is, I was always so fascinated by almanacs when I was young. Like to the point where I wanted to get one, but I couldn't justify it for myself. Like I didn't have any real use for one. But yeah, just the concept of that amount of information in my pocket. Of course, nowadays you have all of that available digitally, but yeah. Yeah, the latest Island Almanac just arrived, and we're having trouble making sense of it. The almanac, which is our puzzle input, lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number. But numbers are reused by each category. That is, soil 1, 2, 3 and fertilizer 1, 2, 3 aren't necessarily related to each other. For example, seeds 79, 14, 55, 13, seed to soil map 50, 98, 2, 52, 50, 48. None of those are seeds. Okay, interesting. Soil to fertilizer map, so that maps the outputs of this somehow to input to input to input. The almanac starts by listing which seeds needs to be planted. Seeds 79, 14, 55, and 13, right? The rest of the almanac contains a list of maps, which describe how to convert numbers from a source category into numbers in a destination category. That is, the section that starts with seed to soil map describes how to convert a seed number, the source, to a soil number, the destination. This lets the gardener and his team know which soil to use with which seeds, which water to use with which fertilizer, and so on. Rather than list every source number and its corresponding destination number one by one, the maps describe entire ranges of numbers that can be converted. Each line within a map contains 3 numbers: the destination range start, the source range start, and the range length. Okay, so consider again the example seed to soil map. The first line has destination range of 50, a source range of 98, and a range length of 2. This line means that the source range starts at 98 and contains 2 values, 98 and 99. The destination range is the same length, but it starts at 50. So its 2 values are 50 and 51. Right. Okay, so it's a linear mapping, but with a weird syntax. With this information, you know what seed number 98 corresponds to. With this information, you know that seed number 98 corresponds to soil number 50. And that seed number 99 corresponds to soil number 51. The second line means that the source range starts at 50 and contains 48 values, 50, 51, up to ticking up to 96 and 97. This corresponds to destination range starting at 52 and also containing 48 values. So seed number 53 corresponds to soil number 55. Any source numbers that aren't mapped correspond to the same destination number. So seed number 10 corresponds to soil number 10. Alright, so if they aren't mapped, they're just the same. That makes sense? So the entire list of seed numbers and their corresponding soil numbers looks like this. 0, 1, and then up to 40, well, up to 50. So it goes just the same up to 50, and then 50 jumps to 52, same for 53, and then it goes 52. 52 is also 52? I guess so. All the way up to 96, which is the second one. Oh, no. Oh, 52 was wait. Oh, right. 50. Wait. Yeah, 50 maps to 52. So 50 maps to 52. 51 maps to 53, all the way up to this 96, 97. These map there. And then 98 and 99 maps to 50 and 51. Right. Whew. Got it. With this map, you can look up the soil number required for each initial seed number. Seed number 79 corresponds to soil number 81, blah, blah, blah. The gardener and his team wants to get started as soon as possible. So they'd like to know the closest location that needs the seed. The closest location. Right. So the last one is a location mapping. So they want to go backwards. Wait. We were down here. The closest location that needs the seed using these maps. Yeah, so they like to know the closest location that needs the seed. Using these maps, find the lowest location number that corresponds to any of the initial seeds. To do this, you'll need to convert each seed number through other categories until you can find its corresponding location number. In this example, the corresponding types are seed 79 needs soil 81, fertilizer 81, water 81, light 74, temperature 78, humidity 78, which maps to location 82. So the lowest location number in this example is 35. Yeah, so you run for all of them, find the lowest one. What is the lowest location number that corresponds to any of the initial seed numbers? Right. I'm thinking we can have some fun with this. So let's grab this as our sample input. So let's just paste this into here. That's fine. And then let's start part 1. Let's just open the sample input in a second tab there. And I'm thinking we'll do npeg again to parse this, and we'll create a sort of smarter a smarter data structure here to do, and we'll do some overloading and some custom types and have some fun with this one. So I realized after I did the last stream that I sort of just blew through the npeg syntax without really saying what I was doing. So for today, I thought I'd bring up the npeg grammar on the side so that you guys can sort of see the documentation, see the syntax for npeg as we write this out. So we're going to import npeg, and again, npeg is a library that you can install like so, and then we'll install npeg. That downloads that. I already have it, so I'm just going to abort that. And we are going to create, so our input, we have these different categories, which is fine, but each of them have these mapping types. So what I want to do, I want to create a custom mapper, or just a map type, which stores these numbers, and then we'll write some nice syntax to make that easier to use. So we'll make a map, which is an object, and a map contains a sequence of mappings, which is a sequence of a mapping, and a mapping is just another object which contains a source start, which is an int, a destination start, which is an int, and a span, I guess, which is an int. So source start destination start and the range, or the span. And then we'll write a procedure which will look like a table. So this looks like the index. A map is an object of mappings with mapping object thing to being mapped. Yeah. It's oh, hi, Derlino. Yeah. Cool that you joined us. Maps and object. Yeah. Mapping. So this syntax here, these are just because otherwise these brackets would be actually tried and parsed as brackets. So we use these to sort of escape these. And this is special syntax for bracket stuff. So we take in here a map. We take in a I guess a source, and that should return as an integer, and that just does for map in or for mapping in map.mappings if source okay, so if source is in the range of mapping dot source start all the way up to mapping dot source start plus mapping dot span. And let us put, wait, how long is this line? It's not 80 characters. We'll keep it like this. Of course, in nim, these are inclusive. This range operator is inclusive by default. So this in our sample input here would go from 98 and then add 2, so 98 to 100, but we only want it to go to 99, as we need to say that we want to go all the way to but not including the end of that range. Coincidentally, you just watched a new episode of Mad Men. Yeah. Oh, I should have the Mad Men intro for this stuff. Mad Men is such a Mad Men is such a good YouTube channel. So yeah, if our source is in this range, then we return the mapping destination start plus source minus, oh, that doesn't really matter, minus mapping dot source start. So if we're in the range from sort start to sort stop, then we return the destination start plus sort of the offset into that range. If we go through this loop and haven't found anything, it's the same value, so we just return source. And now we can see that if we create just a test mapping here, which is a map where the mappings is this sequence of a mapping. Let's do this. Mapping, which has a source start of 98 and a dest start of 50 and a span of 2 and 50, 52, 48. So 50, 52, 48. Then we can do for I in, what was their example? Their example went from 0 to 100 try in 0 to, well, to 99. Echo I, and something like that. And then test mapping. And here we see our bracket syntax. So now we can do that to get our mapping. This will call, this right here will call this procedure. And we can now, if we run this, we can see that it goes all the way up until, what was it? Up until 50. So up until 50, 50 is 52, 51 is 53, and then 52 is 54. And that carries on all the way up to 97, which would be 99. 97 is 99, and 98 is 50, and 99 is 51. So that does our mapping. So now all we need to do is to parse this into a list of mappings. And so a list of seeds and a list of all these mappings. So we create another object, another object, which is our, well, I guess it's an almanac, which has a list of seeds. And then we have a seed to soil, which is a mapping. And then we have a soil to fertilizer. Actually, let's do this. And then a fertilizer to water. Water, which is a mapping. There we go. Then a water to light, mapping. There is definitely a faster way of doing this in Vim, but I can never remember how to do the replacement and capture something and turn it uppercase, and yeah. So we're gonna do it the old-fashioned way. Just hard, laborious work. Humidity to, oops, hit the page down button there. Location is also a mapping, like that. Wow, that's neat. Yeah, the mapping thing, it's pretty cool. Now we can get our parser going, which is a peg. It will take, so the sort of master list here, we'll just call that almanac. And this returns just an A, so that returns an almanac object. So our almanac rule is, and this is where we can bring back our MPEG rules, because now we're going to write a parser that takes an input like this and turns it into this object, which is going to contain a list of seeds and a bunch of mappings. So this almanac, I might just scroll this by accident. I'm just going to double check that I have my arrow pointing the right way, and I don't. That was a good thing. That should be like this. So an almanac starts with the word seeds, and then followed by a number list, and I'm actually going to cheat And I'm going to go to part 1 of day 3, where we also used, oh no, I have completely forgotten my shortcut for closing. There we go. Part 1 of day 4, where we also used npeg, and I'm just going to steal my own implementation of a list of numbers. Like that. So an almanac contains the seeds, list of seeds, and oops, it has that as a capture, followed by a mapping list. What would trigger first? Well, almanac is an object. So objects in them, they're not behind a pointer or anything. We don't need to allocate them. They're stack allocated. So this object, the almanac object, will already exist, which is nice because that means we can just do a.seeds equals this first capture, and we are going to need our trusty string utils package. We are going to split that on white space, and we are going to map that through parse int. And of course, for that, we also need secutils, which brings the mapit thing, this thing. So that takes all the seeds, takes that as a list of numbers. We split on white space, and then we map that through parse integer. So if we now define mapping list as just anything, so as you can see, match this 0 or more times, and this one, which just matches any character, this will just match anything up until it can't match anything. And then we can do grab our almanac, and then we can run our parser. Just echo out that parser on our sample input into our almanac object, and then we can echo out that almanac object. Ooh, attempt to call reader. Something here is wrong. Let's see. Error type mismatch. Split white space 1. What? Oh. Operator precedence. This thought it was turning everything into a string, so it parsed that as 1.split white space instead of this capture string. That should make it a bit happier. And now we have read file. Oh, and I messed up my brackets down there. Oops. That was worse. There we go. No. There we don't go. Found parser. What am I doing wrong? Parser.match, of course, because parser is not a function, it's an object which stores our parser and has a match procedure. There we go. So now we can see that it matched. Okay, a rule was good. Yeah, Derlino commented on Twitch, so much hate having errors in my code. Oh, you were talking about just having like making mistakes. I was thinking about the inline errors. I hate them so much, and I just haven't been bothered to turn them off or figure out how I turned them off. But yeah, OK is true. Seeds is now a list of seeds, which is great because that is the list of seeds that we expect here. So now our mapping list, we need to flesh this one out. And we can do this iteratively by saying the seed to soil followed by just the rest of the input. And then we can define our seed to soil rule as just being the word like this line. So that line followed by a list, one or more number lists separated by a new line, right? So this, we haven't parsed this into anything yet, but we should now see that, ooh, now it was actually false, match length 18. Ah, right. So it came to the end of here, and then it expected to find the seed to soil map, but we of course need to do, so here it expects like the number list immediately followed by a mapping list. That is of course not what we have. We have one or more white space characters before that mapping list. So now it will match on this new line and this new line. And then it will start the seed to soil mapping. Now it should return true, and that is good. But of course we don't have anything here yet because we haven't parsed that in. Wait, why does that? Oh yeah, it's right. This should not be a mapping. This should be a map, of course, because each of these contains multiple mappings. Of course, we don't really need this to be an object, but yeah, let's not change that now because that means changing our procedure as well. Right, so now this should look a bit different. We now just see that we have this empty list of mappings. Now we run into a thing in NPEG which I don't like. So here we have this seed to soil. It now has a list of like a number list. It has more than one number list, and I want to put these number lists into the seed to soil mapping. And I can now set a flag here that says that this should go into the number list, or that this should go into the seed to soil mapping. But yeah, I mean, I guess we could do that just to show how you would do this. So two ways of doing this. We could do this. This is like just capture this, which is going to be, if we echo this out. So we still don't do anything with it. We just write it out. And you will see that this is these lists of numbers. I'm actually going to do it's a bit annoying that this ends with that new line, because if we do this, it won't match, right? We tried this earlier. Yeah, that just matches the first one, which is not really what we want. And 2 won't be anything. Oh, 2 is the second one. What happens if I try to grab the third one? That throws an exception. Interesting. So what we can actually do we get a number somewhere? Let's see, captures. Yeah, capture data, which parts come separated list, string captures, only when parsing the traits. Aha, so we have a captures field. Oh, no. Yeah, right. So this is just if you make a capture, but don't have the code block here, then it will just get added to a captures field in the result of this match function. But that's not what we want. We want this, code block captures. Right, so we have capture. The variables $0 to $9 are rewritten as capture n.s. Right, so we can do, we can grab these out manually. Without the dollar syntax, we can say, is capture defined here? Oops, capture dot length. That seemed to be fine. That gives us 3. Right, 3 is a 1 for the whole match. Yeah, all right. Right, so it has 3. So it has 0, 1, and 2. As I explained last time, 0 is the full string that it matched. And then you have the matches after that. So we can now do for number list in let's just for I in 1 all the way up to capture.high a dot seed to soil dot mappings dot add, and we need to add a mapping, which is so let our number list here. Actually, this isn't the number list. This is only ever 3 numbers. We could set up a separate parser for these, but we're not going to do that. We're just gonna do the same thing as we did here. Parse these out, and that is at capture I. Capture I dot split white space. Let's do that just to make it a bit nicer. On this very large font size and very small screen. So now we can say that this mapping source start, dest start, span. So dest start is number list 0. And let's again, for niceness sake, do this. Source start is the first number, and then span is our second number. So that should actually parse our mapping into this seed to soil type. No, because it doesn't have high, apparently. Not everything in nim does, which is super annoying. I'm not sure why it doesn't just default to length -1. Split white space. A capture is not a string. It's a capture of system.character. So let us convert this to a string. I assume that this, oh no, wait, we can just do .s. Great. Oh, so SI is the offset into in the subject. That's pretty cool. There. So now we have our seed to soil field is set to an object full of mappings, which has a source start at 98, a dest start at 50, span of 2, and a source start of 50, dest start of 52, and a span of 48. So if we now do the same test that we did earlier for I in 0 to 99, a dot, what was it? Seed to soil of I, and just echo out I, and that, we should now see that we're mapping these numbers all the way up to here, and then 50, it starts at 52, and then at the end here, 98 is, so that looks good. Parsing looks correct, which is cool. So now, since we have the seed to soil, we basically now need to just repeat these. And this is where I was saying, like, this gets a bit annoying because these are, it's just a repetition. Of course, we have multiple ways of dealing with repetition in nim. One way we could deal with this is we return an almanac, but we actually return like a parse result, which is the almanac, which is the actual almanac. And then we have sort of parsing data, like just stuff that we need for the parser that we don't actually care about after the result is done. And here we could say like field is a field, and we can say that field is an enum of seeds, seed to soil, soil to fertilizer, like that, and so on and so forth. And then in here, we could start this. So everything starts at 0 by default. So this seeds starts at 0. And then we tick this up and put them and write a function to put the result into the right field. But that's tedious. So what I'm going to do, I'm going to grab all this, and we're going to create a template. And this template is going to be called, actually, let's see if we can do this with a procedure. And we're going to call this a parse mappings. We're going to figure out the arguments afterwards. So we need to have the almanac, but we need to have the field. So I'm going to try and say that the map is a var map. And we are going to take in the capture because we need that. And that is a capture. Actually, it's a sequence of capture, it seems. And this doesn't return anything because it just inserts it directly into this map. We say like that. What happens here? Did not like that. Parse mapping is declared but not used. Well, we can fix that fairly easily. Parse mappings into a dot seed to soil and capture. Apparently a word I can't write. What is the actual compilation error here? Undeclared identifier capture. So npeg, as you can see here, it's a type of sequence capture. Type capture, but capture is not exported. Oh, that's annoying. You know what? Let's try to just make this weaker. Yes. Dirty hack. Oh yeah, that actually worked. It managed to put it into the variable that we specified, which is good. So now, auto and em, it just, you figure it out, resolve it. You know what this, like when you pass in a type, just create a new version of this procedure with that type. So it's kind of like an easier way to do a generic. We could have done like this is equivalent to doing sort of this is a generic function and it takes that generic argument. That's the same thing. It's just a shorter way of writing the same thing. Now we can do seed to soil. We can say soil to fertilizer. That is this one. Well, soil to fertilizer map, and that of course parses into the soil to fertilizer field. And of course we need to go up here and say that after our seed to soil map, we expect a soil to fertilizer map. There we go. So there we go. Now we have a seed to soil mapping. We have a soil to fertilizer. But we're not matching. And it failed after the seed to soil map. It failed. I guess this is the same new lines thing that we ran into with the almanac parser. Yes, it was. Now this is true. And our soil to fertilizer now contains mappings. Great. So that is great. We'll just continue adding these. Fertilizer to water. Fertilizer to water. Fertilizer to water. Actually, let's make a new pattern here called new lines, which is plus like that. Actually, let's just call it N for brevity. That means we can just do this. And followed by an N, followed by fertilizer to water. And actually, just to make these a bit nicer, I'm gonna do that. And we're gonna say that each of these are individually followed by a list of new lines no one really cares about. Now we should have our fertilizer to water map. This is true. Our fertilizer to water now has a bunch of mappings. That is good. Next on our list is water to light. So water to light, water to light, and water to light. Of course, we also need to add it in here and say water to light. Again, we can see that we add this to our list. Water to light now has these. And our next one is light to temperature. This is tedious. We're going to try to speed it up a little bit. Water to light is light to temperature. Yes, light to temperature. Light to temperature. And oops, and our very last one, I believe. Oh no, we have two more. Now it's temperature to humidity. So replace light to temperature with temperature to humidity. And for our very last one, it's humidity to location. Humidity to location. There. And this is humidity to location. We need to add these to here. Say light to temperature, temperature to humidity, and humidity to location. And we are going to, I think we can add breaks to peg patterns, I believe. Yeah, so now that is the last thing that our file can contain. So now we just map and say nothing more. Our friend the line break, yeah. It's added again. I mean, even some of these are sort of splitting over lines, but it's not that much. So I'll let those slide. So now we can see that we have, humidity to location didn't work, and we got a false result. Something is wrong here. Humidity to location map. Humidity to location map does not have any new lines following it. There we go. Now that matches true. Humidity to location has some values in it. And our almanac parsing is complete. Of course, in retrospect, I'm not sure we would have needed to do these as explicit. We could have just made a list of them, a list of maps. Would have saved us a bunch of typing. We could have said just like whatever map. It wouldn't have been like you wouldn't be able to shuffle them around, but the input is probably good. So let us try one of these full ones. So let us map seed all the way, seed 79 all the way to location. So let's seed 79, and then we want to echo out seed, A seed to soil, seed. Oh, that's a bit ugly. I think, So the problem here is that we need to take this almanac as the first object. So we can't chain these. I can't do like dot whatever soil to whatever. That's a bit annoying. Let me just write a quick template. Ooh, I don't know what to call that. Let's just call it 2. This template takes in a from, an F, a T, and an N, just all untyped. Returns an untyped, and it is going to do A, which is just going to grab from the environment, and then from to T, so from to 2, and N. Can't you just do a second dot product with type map as input return? Well, I could. The problem is that this one returns an integer. So if we had done this with types, and said that sort of seeds is a list of type seed, and seed to soil is a mapping from seed to soil, then we could have been smarter with these, and said that we take in one type and can convert it to another type, but we didn't do that. So we're going to cheat and use a template. So I'm just going to say, what am I going to say? I'm going to say 2. I'm going to say, 2 is actually a horrible name. Convert. So convert a seed to soil, our seed number. And of course, we want our seed number to go first. So seed, convert from seed to soil, convert from soil to fertilizer, and convert fertilizer to water, and convert we want to convert water to light, and we want to convert light to temperature, and we want to convert temperature to temperature to humidity, and we want to convert humidity to location. There we go. Run this, and we get the number 82, which is the mapping from seed to location. So what's going on here? This convert looks super cryptic. Convert, it's a template. We're doing meta programming here. It's basically taking the call to convert and outputting this code. The reason why we don't have to do any like dirty or anything like that is that this A is defined up here for the convert, so it sees what A is. I think if we do this, oh well, it might work. Yeah, that works as well. So at the invocation sites, it sees that, well, there is an A in this scope, so I'm just going to pull that in. This with the sort of backticks, it's just a way to combine identifiers. So we're saying take the F identifier, the literal word to, the T identifier, and just combine those into an identifier. So for example, for our first one where we call it with seed and soil, it's going to be converted to seed to soil, and it's gonna just glue those together into one identifier. So it's seed to soil, then it's gonna do N. And this works because NIM has uniform call syntax. So these two are the same thing. Otherwise, we would have to specify our second one with a capital. We don't have to do that. So this works. It's a bit ugly, but it works. Another option we could have just done. Actually, we might do that. It's a bit prettier. We can say here a procedure called to, which takes a number and takes a. Ooh, it can't actually be. No, we need the from as well. Yeah. Never mind that. We built our object in a stupid way. if we had built this object in a more sensible way that sort of tied these maps together, this would have been nicer. But you live and you learn. If this was production code, I would have refactored this. But we're gonna run this once, maybe twice. So it's gonna be fine. So yeah, let's not echo out this. Let's turn this into an assert on the OK field. So it just checks that the parsing is okay. And it prints out 82. Of course, we don't want to print out 82. We want to do all the seeds. So for seed in a.seeds, so our almanac, the list of seeds in our almanac, we're going to see our numbers 82, 43, 86, and 35. 82, 43, 86, and 35. Our goal is to find the lowest location number. And yeah, what is the lowest location number that corresponds to any of the initial seed numbers? So we're just going to do smallest location is int.high, and we're going to say that smallest location is the minimal value of smallest location, which at the moment is a huge value, and the call to this chain of functions. There, and then we are going to echo out our smallest location. So this should now echo out the number 35. There we go. So now we can set this loose on our actual puzzle input. We'll save that in our day 5 folder. We can delete that line. We'll run this on input.txt instead of our test input. And then bada bing, bada boom. That's should be our solution. So I actually didn't look at this. Oh yeah. So this one has some large numbers and some large ranges. So if you did this in I was thinking initially that the mapping was going to be more complex, and I was thinking of setting up tables and just iterating through these and adding all of the numbers to a table for that table lookup speed. I opted not to do that and do something simpler. And looking at these numbers, I'm pretty glad we did, but because I think those tables would run my machine out of memory. But yeah, that runs pretty quick. Gives us a number. Throw that in there. That's the right answer. 1 gold star closer to restoring snow operations. So we spent the same amount of time on this as we did on yesterday, I think. So it's nice sweater. Ah, thanks. It's a home knitted one from my mother. Traditional Norwegian pattern. Yeah, but hopefully we now have some we now have everything we need to breeze through part 2. Nope. Close that. Just open up part 2 of day 5. And let's go have a look. Part 2. Everyone will starve if you only plant such a small number of seeds. So one set of seeds. Rereading the almanac, it looks like the seeds line actually describes ranges of seed numbers. The values of the initial seeds line come in pairs. Within each pair, the first value is the start of the range, and the second value is the length of the range. So in the first line of the example above, 79, 14, this line describes 2 ranges of seeds to be planted in the garden. The first range starts with the seed number 79 and contains 14 values. The second range starts with seed number 55 and contains 13 values. Now, rather than considering your 4 seed numbers, you need to consider a total of 27 seed numbers. In the above example, the lowest location number can be obtained from seed number 82, which corresponds to soil 84, fertilizer blah blah, and location 46. So the lowest location number is 46. Wait, how is that possible? If this was 35. Oh, because the 35 came from a range or a number, right? Consider all the initial seed numbers listed in the ranges on the first line of the almanac. What is the lowest location number that corresponds to any of the initial seed numbers? I just realized something. I think, a bit depending on how fast you type, I think the fastest way to solve this... Oh no, there's a lot of numbers here. Never mind. I thought... I was like, wait, couldn't I just have typed in all the possible locations? But no, that would have taken me ages. Well, that's not a problem. Let's do count. Well, let's write a new for loop here. So for I in count up 0 to seeds dot high, and go in steps of 2. So this will do 0, then it will do 2, and in our case it will time out, or it will reach the end of our sample input. So now we have 2 numbers. Now we can do for seed in seeds I dot dot seeds I plus seeds I plus 1. That should give us the range that we need. Ooh, why did of course, almanac seeds, not just seeds. There we go. Now we can try to run part 2, and hopefully it's fast enough. Pretty fast. Oh, this was the test input. Yeah, we got the right number, 46. So let's try to run this on the input. Hopefully it's our solution will be fast enough. I'm not sure it will be, but it's be interesting to see. It's working. It's working. Okay, this is actually taking so long that I'll compile this with well, let's just use danger. Why not? There we go. Look at that speed. I want to try this in release mode as well. Oh, it was just compiling. Now it's running. This looks a bit large. I think danger mode actually, danger mode might have done something weird there. We can try. I think this number is way too big. Yeah. That actually gave us a hint. Yeah. I think this is gonna take a while. We could, for an easy speed up, do memoization. Might be enough. If we're lucky. Well, no, that probably wouldn't be. I think that would be slower because we would be adding a lot of numbers to tables. I wonder how far along it is. Kind of tempted to stop it and add some logging to see if it's actually getting anywhere or if it's just stuck. I mean, it's doing something. I can hear the fan on my computer going. This is gonna take a while, isn't it? Let's just see what this says. Like what kind of speed? Like how long are we thinking this would take? It has 18 numbers to go through. It does 2 at a time. But it takes a while to look through one range. These ranges are huge. Oh. It's getting somewhere. Let's have a look at the hint, shall we? That's not right answer. Your answer is too high. If you're stuck, make sure that you're using the full input data. Ah, right. Okay. That was much of a hint. So we need a quite serious speed up. What makes this slow? We have a lot of iterations. Are we checking numbers more than one? Let's just keep that running. We'll head into the folder again. Day 5. Just let us look at the code. Maybe it just actually manages to run through all these at some point. Oh, seems to have got kind of stuck. What's the input like? Yeah, so this was just a pretty small one. Now it's doing this one, I guess, which is long. And there are some even longer ones up ahead. So yeah, we do risk that we have overlap. Should be pretty easy to check. Let's write a small script to just check for overlap. So just skip all of, oops. Don't do that. Do these. How do we do overlap? Let us import the intsets module. Have a set, an inset, which is an inset, and then inset.include our seed, and then old card is inset.card. If old card equals inset.card, quit one. So basically just keep adding them to a set, and if the set didn't change size, we know that the set was already in there. Oh, that didn't run it. This is also going to take a while, probably. But yeah, it doesn't immediately look like it has found any... Oh. It completed. That's the right answer. You're one gold star closer to restoring snow operations. Great success. There's probably a smart way of doing this. In fact, for all of these, like, if your solution is slow, if your solution takes a long while, you're probably doing it in a dumb way. Like, the whole premise of this thing is that if you're using smart algorithms, you can code them in anything because the language is not the limiting factor. So if stuff is taking too long and you're thinking, what if I add threads to this? That's not the intended solution. Because anything is supposed to be fast enough. So this was a bad solution, probably. Someone says, hi on YouTube, what are you doing? We are solving Advent of Code. The Advent of Code, the Advent coding calendar. And we just did day 5, and we're going to start day 6. We're solving these in Nim. So yeah, if you know the clever solution to these, please let me know. I'm curious to see how this sort of stupid just map directly. I mean, this is probably not the fastest thing in the world. I'm guessing there would be a... You're on the right track with part 2, I think. Took me a long while. My epiphany came when I analyzed the actual input mapping characteristics. Oh, so there is a trick. So my initial thought when I read the first one, like the problem here, we are looking for the lowest location, right? We're looking for the smallest location. So why are we going seed to location and not location to seed and just stop when we find the first one? For this, it didn't make sense because these are 4 numbers. These are a lot more than 4 numbers. It's 4 plus 37, and they can just also be 0 to... They can be the other way around. But I think that maybe for part 2, how big was my answer? It wasn't that big. So 1.5 million. What would ticking from 0 to 1.5 million give us? And then just run everything in reverse. I mean, that range is shorter than this first section alone. So that would be way faster. That would be plenty fast enough, probably. But yeah, that was day 5. Let us crack on with day 6. Hopefully, a day of respite after this slightly tougher day 5, which I kind of bumbled my way through part 2. SR Eagle, if you have, took you a long while. Your epiphany came when you analyzed the actual input mapping characteristics. If you, please share details. I really want to know. Day 6. Wait for it. The ferry quickly brings you across Island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here. But you don't see anything besides lots of water and the small island where the ferry has docked. As you try to figure out what to do next, you notice a poster on a wall near the ferry dock. Boat races. Open to the public. Grand prize is an all-expense-paid trip to Desert Island. That must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. And we are apparently speedboat champions? You managed to sign up as a competitor in the boat races just in time. Do we even have a boat? We have a rowboat, I think. Oh no, we left that. We took the ferry here. The organizer explains that it's not really a traditional race. Instead, you will get a fixed amount of time during which your boat has to travel as far as it can. Okay, and you win if your boat goes the farthest. So it's kind of a reverse race. As part of signing up, you get a sheet of paper, or it's more of an endurance race, I guess. Oh no, it's a time limit, yeah. As part of signing up, you get a sheet of paper, which is my puzzle input, that lists the time allowed for each race and also the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure you go farther in each race than the current record holder. That's a tall order. The organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They're actually toy boats, each with a big button on top. Holding down the button charges the boat, and releasing the button allows the boat to move. Boats move faster if their button was held longer, but time spent holding the button counts against the total race time. You can only hold the button at the start of the race, and boats don't move until the button is released. Aha, I see where this is going. For example, time 7, 15, 30. Distance 9, 40, 200. So this document describes 3 races. The first race lasts 7 milliseconds. The record distance in this race is 9 millimeters. The second race lasts 15 milliseconds. The record distance in this race is 40 millimeters. The third race lasts 30 milliseconds. The record distance in this race is 200 millimeters. Okay, I thought that sounded like a lot, like quite a high speed, but your toy boat has a starting speed of 0 millimeters per millisecond. For each whole millisecond you spend at the beginning of the race holding down the button, the boat's speed increases by 1 millimeter per millisecond. So, because the first race lasts 7 milliseconds, you only have a few options. Don't hold the button at all. That is, hold it for 0 milliseconds. At the start of the race, the boat won't move. It will have traveled 0 millimeters by the end of the race. Hold the button for 1 millisecond at the start of the race. Then the boat will travel at a speed of 1 millimeter per millisecond for 6 milliseconds, reaching a total distance traveled of 6 millimeters. Hold the button for 2 milliseconds, giving the boat a speed of 2 millimeters per millisecond. It will then get 5 milliseconds to move, reaching a total distance of 10 millimeters, so on, so forth. Hold the button for 7. That's the entire duration of the race. You never let go of the button. The boat can't move until you let go of the button. Please make sure you let go of the button so the boat gets to move 0 millimeters. Since the current record for this race is 9 millimeters, there are actually 4 different ways you could win. you could hold the button for 2, 3, 4, or 5 milliseconds at the start of the race. In the second race, you could hold the button for at least 4 milliseconds and at most 11 milliseconds and beat the record. A total of 8 different ways to win. I think we're counting ways to win. In the third race, you could hold the button for at least 11 and no more than 19 and still beat the record. A total of 9 ways to win. To see how much margin of error you have, determine the number of ways you can beat the record in each race. In this example, if you multiply these values together, you get 288. Determine the number of ways you could beat the record in each race. What do you get if you multiply these numbers together? Yeah, button press in milliseconds. I like how it just... Yeah, sure, I can just calculate this and then I can just reliably hold the button for a set amount of milliseconds. No problem. We're gonna win this race. So, do we need this still? Well, I guess we do another MPEG parse of this. It's a pretty simple one, but that has never stopped anyone. Import MPEG. Let our parser be a PEG that starts at, I don't know, let's call it records. And it has a return value, which is, will just be lazy. We won't create a proper type for this. It has a list of times and a list of distances. Times, distances are both sequences of integers. And records is just a time list followed by a distance list, followed by nothing more. Then a time list is just a let's open the sample and put it here. For day 6, that is just time, uppercase T, colon, followed by one or more space characters, followed by a number list, which we are gonna capture. That should not have an E at the end. And the distance list is just pretty much the same thing, but just with the word distance. And of course, we are going to go again and grab the number list parser from our earlier result, or from our earlier parser. We're going to say that these have to be separated by a uline character to satisfy the thing. So that should be good. That should match numbers. Now we can say that our result.times is equal to our capture split white space, map it. Or actually, we can just do map since we're only doing one thing. Parse int. And we can do the same thing here, but not say times, say distances. Of course, we need a trusty input of stereo-utils and sec-utils. I'm not sure if you noticed, but I like to write my standard inputs first. So standard library input first, then package inputs second. So external packages. And then I would do like a local module last. Just the way I like to sort them. I'm not sure, is that something that other people do? Now we need to refer to our type again. That's a bit annoying. Records is equal. I guess we can make this an object then. Records. I mean, we could just do that, but since we're defining an object anyways, since we have to define a type anyways, we can just do it like that. Records is records. Echo the parser match on read file of our sample input, like that, and then echo out records. Oh, of course we need our records there. Oops. That should parse these into two nice lines. We have a false result. That is simply because our file does not end with nothing. It ends with a new line. And then nothing more. Now it matches the entire file, which is good. We have our times, we have our distances. Now we can do our thing. So we can just assert that this is parsed okay. So yeah, basically we loop from 0, or I guess we can go from 1, because 0 will always move it 0. So we go from 1 until the number before this number, because this number will also be 0. And then we find, we see which of these will win over this one. So let's loop through records.times, and then for hold time in, we actually need to name this something. Time in records the time, and 1 ... lower than time. So from 1 to time non-inclusive. That is our hold time, and that is our how long we're holding the button for. So if we hold it for 1 millisecond, our speed is 1 millimeter per millisecond for 6 milliseconds. So we time the remaining, or we time the two values together. That gives us our speed. So we do time time minus, so we do our hold time, which is directly equivalent to our speed, times by the time minus the hold time. So in the example of 7, for example, this will loop from 1 to 6. I would say 1 times 7 minus 1, which is 6. And then we say if this number is larger, of course we now need to get the index from that as well. Records.distances at that index. And we need a possibilities is 0, sum is 0. Actually, make sum 1. I'm going to show you why in a second. Then possibilities plus equals 1. And then at the end of this loop, times sum with possibilities. So what? Oh, possibilities. So what this is doing, we're setting sum to 1 because we are going to time these up. So and this one counts up the possibilities. So where our score is larger than the distance record, we add 1 to the possibilities. And then we want to time this into our running sum. So we started at 1. So the first possibility is just set to, and the first time we have possibilities, the sum is just set to the possibilities. And then after that, we time it up. And then we can echo out our sum. That should give us 288, which is our test score there. Actually, let's open this. Okay, so this isn't too horrible. Should be plenty fast, our solution. At least for this first one. Part 2 might throw a major curveball at us. Let's see what we get. 800,280. Pop that in there. That's the right answer. 1 gold star closer to restoring snow operations. That was pretty easy. Fits in 1 page even. Not even a single line break. Right, so we have some more details from SR Eagle here. Regarding day 5 part 2, you mentioned linear mapping at the beginning of the stream. And then you give me a number. Base 64 would be a strong hint / spoiler. Parser for day 6 is nice for practicing NPEG, but kind of a waste of time. Yeah. This total overkill. I just wanted to show people NPEG more. But I specifically watched your stream to learn from your structured approaches and educational sidetracks. Yeah. Thank you. What is this base 64 number? Wait, are these? Range partitioning. Oh wait, I guess you coded that so people watching the stream. This is 2 days ago. Close, like, cover your ears, or I guess mute the stream if you don't want to hear this. The decoded message was range partitioning / overlapping. So yeah, I guess. Wait, range partition. How would you do that though? So seeds would map to I'm too tired to think about this kind of stuff. You don't have top check every single seed in a range, just the interesting edge cases. Right. Right, so wait, you can check the first and last one of a range. Maybe even just the first one. Yeah, if you check the first and last one of a range. No, but they can map through multiple non-contiguous sections. I think I have to think about that a bit more too. Yeah, so it's basically you have to find the edge cases. You have to figure out which parts of the input is interesting, and which parts are not. Anyways, part 2 of day 6. As the race is about to start, you realize the piece of paper with race times and record distances you got earlier actually just has very bad kerning. Kerning is a fantastic thing. Or bad kerning is a fantastic thing. So basically the, as you can see here, A and V, just aligning them like this would make it give this way too much space. So we just kind of slide the letters into each other a bit. There's a fantastic subreddit called r-keming, and keming is just the word kerning with bad kerning, and the whole subreddit is just filled of people discovering places that have bad kerning. Yeah, there's only one race. Ignore the spaces between the numbers and each line. So the example from before, 7:15:30, 9:4:20, now instead means this. Now you have to figure out how many ways there are to win this single race. In this example, the race lasts for 71,530 milliseconds. Almost or slightly more than a minute. And the record distance you need to beat is, actually, that's quite a distance. 940 meters. Well, I guess a kilometer in a minute. You could hold the button anywhere from 14 to, wait, what? Oh, right, you could hold the button anywhere from 14 to 71,516 milliseconds and beat the record. A total of 71,503 ways. How many ways can you beat the record in this one much longer race? So, this one will be pretty easy. I just want to check if we just do it and see if it's fast enough. So let's just be lazy about this. Instead of split white space, we are going to do a replace of spaces with nothing. So empty characters there. So replace these with nothing. That should give us the two numbers that we are looking for. Let's actually just check that that's right. Oh no, now I did part 1. Wait. Oops. There. And then redo all my things and write this out to file part 2. And let's open part 2 in day 6. There, okay. And run part 2. No. Right, replace. Oh, right, this doesn't return a sequence anymore. So let's just do, oops. Let's just do this. And because I'm lazy, let's just do add instead of replacing that sequence with an integer. Let's just add it to a sequence which now just holds one element. That's our true input. There we go. 71503. 71503 ways. So if you now do the actual input, we can do this. We can grab our score. That's the right answer. You're 1 gold star closer to restoring snow operations. So this, again, like as we discussed for day 2, part 5, this is about finding edge cases. As you can see, so the winning time will always be in a range, right? So if you're sort of at the point where you get faster, well, I guess this is where we get faster because it was 9 seconds, or 9 millimeters. So this is where we get faster, and then we will grow in speed, diminish in speed, and at some point we will go below the limit. So the fast way of solving this harder one is to just go from both sides. So first find the first number where we're faster, then go from the opposite end and find the highest number that's faster, and then just do the math of this minus this is this. Super easy. Would be, it should be quite quick. Unless this is very close to the optimal solution, then it would be slower than doing it the way I did. But NIM is pretty fast, and this is not a hard problem, so to speak. Right, so the input is the same. So our numbers are, yeah, numbers are pretty high. So we just basically blew through 0 to this number, or 1 to this number minus 1. That's 54 million odd numbers. And it takes that long in a debug build. Actually, how fast is this? Just compile it, run it under time. Barely, time is barely able to, oh, command not found. Oops. There. Okay, so it is able to measure it. This is in seconds, so it's slightly more than 1/4 of a second. If we run a release build, we can see our time is dropped by an order of magnitude, almost. Way faster. For slower languages, you have to visualize it to get at the underlying optimization problem. It's a quadratic curve, so simple math. Oh, for the part 5, oh, part 2, day 5. Yeah. Quadratic curve. Right. Wait, part 2, day 6? Isn't this just a... Wait, what's a quadratic curve? Am I thinking of something else? Oh yeah, yeah. It's a quadratic curve, yeah. So yeah, basically the speed, as we hold the button down, the speed will increase up until some point we sort of get diminishing returns and we come back down. And basically it's about finding this point and just figuring out how many points are above there. It's easy. You have to use quite a slow language for that not to be fast enough. If this takes 72 milliseconds. I'm still a bit annoyed at yeah, close this. I'm still a bit annoyed at day 5 part 2 though. I just don't see the I don't see the way to optimize this. I mean, apart from what I mentioned of just going the other way. Because that would be way faster. Because the number we were looking for is a small number. And here we are going through a bunch of numbers. So if our number is smaller than this number, then going the other way would be faster. And in this case, it would be. But I'm not sure how. So these numbers map through this, which is just like, I guess like a sawtooth-ish function, which feeds into another sawtooth-ish function, which feeds into another one, and another one, and another one. And how do you know what comes out the other end without calculating your way through? I guess it's about finding, as you mentioned, finding edge cases. So all of these ranges are linear. So if you know your starting one, you can do the first and the last in each of these sort of linear ranges. But then you need to do the same thing for the numbers you map to. It's quite a bit of logic in there. To go through these in a good way. Anyways, I mentioned we have a bit of time. It's only 10 p.m. Split the seed range on the edges of mapping ranges, if needed. Wait, split the seed range. Oops. Split the seed range on the edges of mapping ranges. So this range up through these numbers, we split it up on these ranges. Right. Yeah, so for this range of numbers, which is this many numbers long, you find the mappings that apply to this range. So you find the mappings. And then for the top and bottom of each number in each mapping, you have a look in the next one. No, yeah, so for each of the ranges that apply here, you look at each of the ranges those map to in this one, and go all the way through and grab all your ranges. And then you find the lowest range in here, or the lowest number of those ranges, and go back up. Maybe I will hack away at that. I will mine some diamonds off camera, and then maybe I'll come back tomorrow and show the good solution for that. But I mentioned that I wanted to take a look at someone else's solution. So this, as we can see, we have now traveled first to this island and then over to this island. And it looks like we now have won our all expenses paid trip over to Desert Island over there, which is going to be tomorrow. So this is part of the reason why I don't do these as they go live or try to make the leaderboard or anything. This one is going to be available in about 8 hours. That means it's going to be available to me. It's 10 p.m. now, so that's going to be 6 a.m. I'm not going to get up at like 5 a.m. to solve these before I go to work. Not gonna happen. I wake up after 6. Yeah, let's have a look at the forum. Ooh, forum dark theme. Yes, please. Element of code. So this guy, free flow. He appears to be new to NIM. And oh, actually he has realized the error in his ways. Oh, I'm just kidding. So he's writing them in something called Twin Basic, and in NIM, and he noticed that his NIM times are way worse than his Twin Basic times. This should say seconds. I checked the code and it actually runs for about 2.5 minutes. Well, yeah, it runs for 2.5 minutes on my machine, which apparently is quite a bit faster than his machine. And if we look at his solution, which is here, I downloaded this code. It's not quite complete. Oh, he has actually pushed some more stuff since I looked at it. Oh no, these were here. Yeah, no. But yeah, he has a relative import outside of this folder or this repository. I guess he might have that on GitHub as well. Doesn't actually look like it. Nope. So he has a library of some helper functions outside of this. Fortunately, the only thing in there was this AoC data path. So I just commented this line out and this line out, and I just hard coded the input.txt in there. I also fixed up some he has some like formatting today, so I just manually punched the day in there. But basically, looking at his code, apart from the very strange formatting choices, this I checked. It's a ruler. So this is 10 characters, 20 characters, 30 characters. I'm not quite sure what he uses it for, because it doesn't appear to like line up these things with, like, this is at 49 and 51, these two characters. No idea why he insists on putting his types way over here, which just makes this much harder to read. But the reason why his solutions are slow is this kind of like a sequence of strings, which isn't necessarily a bad thing. This initialize function does quite a bit of work, but like he first replaces extra spaces with less spaces and does some weird things like this, which in NIM probably creates a lot of string allocations. He then goes on to do like create this ordered table, and then he loops through what he split out here and puts everything out. So it's very allocation heavy. And then he gets into sort of the meats of his solution here. Again, it's a sequence of a tuple with a string and a sequence of strings. A lot of memory allocations going on here. Then he starts looping, runs this winning number every loop, which is it's fine. This isn't particularly expensive. It's not a great way of doing it. Like you're looping from one number. Yeah, you're looping through a number and checking if one number is in another sequence. So he has two sequences. He goes through and like tries to find them, which is expensive, looking through sequences like that. I think in my solution, I turned these into sets and looking for, and did the union of the two sets, which is a much faster operation. But yeah, and then he parses in every iteration of his loop, which of course is not very quick. And then he loops through, so my wins is a number, and he loops through it, and then he adds these cards. So again, allocation, you add them into this sequence, which keeps reallocating the sequence as it grows. And of course, you end up, I don't remember the total number of cards, but there were quite many. So you have a massive array of cards. There's no caching going on here. So for each time he finds a card, there's no cache of the value that, like, of the winning numbers, for example. So he doesn't cache this, which makes this every time he encounters a new card, it keeps running through and doing this kind of expensive search. But the biggest offender is, or the biggest slowdown for sure, is the memory allocations. Just allocating so many strings in this big massive sequence, and then this horrible looping that is not very efficient at all. And of course, parsing an int that you could have just parsed, like if you had just parsed it out here, instead of parsing it and splitting the string, parsing it every single time, it would be so much faster. So this, my sum cards, my index 0 dot split, that is splitting this space, and then grabbing this number, which he has as a number, and turns it into a string, only to parse it back out to an integer afterwards. And despite all that, despite this being quite slow, I downloaded it, and I compiled it. As I said, I did some minor tweaks just to make it compile without this helper library. If you run this, you see it finds part 1 fairly quick. But running this, it takes about 2.5 minutes, and it's basically just, as you can see, my memory grows. This number of, or this my CPU usage goes through the roof. It's basically just allocations, a lot of repeated work. Yeah, and now I was at 8 gigabytes just a minute ago, and now I'm at 10 gigabytes of memory. If he has a machine with sort of, if he has 4 gigs mem, then he's gonna be using swap for this. That's going to be a lot slower. He appears to be on a Windows machine as well. I'm not sure how those handles swap. Yeah, now we're at least 5 gigs memory consumption. 5.5. I don't remember when I started this. 6.5. I didn't look when it started either. I looked at it first when it was at 8. So we're allocating. Now it's at 15. So we just allocate gigabytes and gigabytes and gigabytes of strings, and those allocate time.